Greetings, everyone. My name is John Gabriel, and this is the new Calculus channel. The photograph you're looking at there is one of me taken yesterday when I turned 60 and 1 day. So in this video, I'm going to be talking about the second definition in Book 5, which is also a very important definition because it is all about measure and how the ancient Greeks established the operations of arithmetic using magnitudes. So let's begin. Now, definition 2 says, and the greater magnitude, that is a multiple of the lesser when it is measured by the lesser. Okay, so of course the greater can also measure the lesser, but it'll be parts of the greater, or equal parts rather, of the greater. So if P and Q are magnitudes with Q less than P, then we say that Q measures P if and only if P divides if P divided by Q leaves no remainder. In other words, P is a multiple of Q. Okay. So this is what the measure problem is about, okay? So we have, let's say, something like this where we want to measure using this unit here, and I've put spaces in between it to make it easy, but they could have all been right next to each other as one unit, and the same with these red blocks. But I'm using the red blocks to denote the dividend, the blue blocks a divisor, and the green blocks the partial quotient, which I'm going to be putting up here, okay? So what we need when we divide is, when we measure using division, is we need to know how many times we can measure this red line here, and I'll call it a line, but it's a series of blocks with this blue line, okay, which is a divisor. So if, for example, we said, let's choose a quotient of 1, right? So if we just said, let's say this measures the red block 1. It doesn't matter what you put up here. I mean, you can put up as many blocks as you like, because every time when you do this multiplication, and I'll show you that you don't need numbers to do it, then the subtraction process will automatically adjust. So even if you had to measure past this red line, it would adjust to give you the right answer. But that's why I just chose 1. You can put any number you like up here, okay? So if you do that, then you want to know how the multiplication here happens between the blue and the green, right? So the multiplication happens like this. So if you've got 3 of them and 1 like this, then you only need 3, right? And that is what you see there, 3 at the bottom, right? Okay. And so if we subtract these 3, then we'll end up with something like this. And now over here, I'm going to choose 4 of them, which is going to overshoot this length, okay? So in other words, I'm going to try and subtract 12 from 9, which is no problem. And again, I know that 4 times 3 is, so this is still 3 here, and I want 4 on this side. That means this length here is going to be 12, okay? 12, right? Okay. So I'll come back here now. So if we subtract this from this, we're going to, so we know that this length of 4 times this length of 3 will give us this length of 12. And if we subtract them, we're going to end up with these 3, right? Okay, and so that's okay. They're negative, and we know once again that 1 times that is this, okay? So, and we know that if we subtract these 2, we have no more remainder, and we're left with the answer, which is the sum of the partial quotients, right? And that will give us a final quotient. And so if we add all these blocks, we'll have 5 blocks, and if we take 1 block away, we'll have 4 blocks left. And that is, 4 blocks is exactly the measure of this red line using this line here, okay? In other words, that's what we have, okay? So it doesn't matter if you're under or over, you just choose something that you think is approximately close to the measure. And this works much easier with numbers. Now, I have videos out there which explain all these things with numbers. So, for example, understanding long division or teaching long division is one of the most popular ones. You can look it up on my YouTube New Calculus channel. You can type in teaching long division and it will explain this using numbers. So what I've done so far is I've shown you that you don't need any numbers or anything to understand the second definition, okay? And so the second definition basically defines the concept of multiple. Right, so I'm going to stop there, and hopefully in the next or in the near future I'll carry on with the other definitions. But book 5 is the most important book out of all the elements. It surpasses all the ideas that the ancient Greeks had that are displayed in all the other books. Okay, it is a reason that you do all the things that you do in arithmetic with fractions, with numbers, with algebra, and all those things. And of course, number in book 5 doesn't exist yet. It is only introduced in book 7, definition 1, through the abstract unit, whose size, by the way, doesn't matter any longer, but the properties are transferred, right? So, for example, when you're working in book 7 and you're dividing by a certain number, it's assumed that that particular number can be divided into, let's say, 3 equal parts, like you see here. See the unit, 3 equal parts, or whatever you're dividing by. Okay, so I'm going to stop there. I'm John Gabriel. This is a New Calculus channel. Till next time, goodbye.